Okay, so day before yesterday we were talking about the threads, okay, and the importance of using multi-threads, okay, and I think we also had a brief discussion about how we can handle the synchronization, thread synchronization, okay. So just to refresh your memory, thread synchronization is very much important concept, okay. So thread synchronization is the ability to access the critical code, okay, to be accessed by only one thread at a time. Okay, so if the critical piece of code is being executed by more than one thread at a time, there may be a chance that data inconsistency can occur. Okay, so I will go through with some examples, that way you can relate, like how this synchronization is required, what is the importance of synchronization. Okay, I think last class I have explained about printing the check numbers, right? And now today I will have one more example, so most of you, you might be using like in a book my show, right? When you were in India, so we used to use that app very much, like to book the movie tickets. Okay, so I will show you the example where, more than one thread is trying to book the tickets. Okay, and how, if you don't implement this thread synchronization, what would be the impacts, how I said that data inconsistency can occur if you don't utilize thread synchronization, right? So I will just show you one example how that works. Okay, I just written a simple program. Okay, if you see, basically the job of this program is to book the tickets. Okay, I have total 3 tickets available, okay, for the movie, and I do have 3 threads trying to book those three tickets. Okay, so I have 3 tickets available, but 3 folks are trying to book the tickets. First guy wants to book only 1 ticket. Second guy wants to book 2 tickets. Third guy wants to book 3 tickets. So total availability is 3, but with the 3 people out of the 3 threads, I'm trying to book total 6 tickets. Okay, so I do have a condition, to see that, what is the number of tickets that particular thread or guy wants, and whether this number of tickets required is less than or equal to the total number of available tickets. Then only I am saying to print or to book the tickets. If not, you say no ticket available. But still, though I have the condition to check whether the thread which requires number of tickets required for the thread is less than or equal to the total number of tickets, but still, the data synchronization issues may come. How it is? Because we are using multi-threading concept, right? So I'm using 3 different threads: thread 1, thread 2, thread 3. So these 3 threads, okay, so I'm starting these 3 threads, okay, and as soon as I invoke with the start method for that particular thread, right? So all 3 threads try to access the same method. Book ticket is the method. If you see, when I declared, sorry, ticket booking is the one, okay, will be invoked, because that is what we created the thread. I created T1, T2, three threads, and I'm saying invoke ticket booking function, right? So ticket booking, so if you see, I am passing thread 1, thread 2, thread 3 to the ticket booking function, right? So if you see here in the ticket booking, what I'm saying is, if the thread 1, okay, try to book only 1 ticket. If thread 2, book only 2 tickets. If it is thread 3, book 3 tickets, I, J, K, right? If you see, I equal to 1, J equal to 2, K equal to 3. So from here, I will working one more function called book tickets. Okay, so in the book ticket, what happens? So 3 threads try to access the same number of tickets, which is 3 tickets, but 3 people trying to book 6 tickets. Okay, since the same piece of code being executed or being invoked by more than one thread, let's see what's going to happen. You see, 2 tickets booked by thread 2, 1 ticket booked by thread 1, 3 tickets booked by thread 3. Since like now I do not have any control on this particular piece. Okay. So at the same time, three threads try to access. Okay. And the availability of the tickets is showing as 3 for all these three threads. That's how they're able to book the tickets. So this is a classic example for thread synchronization. So in order to avoid this kind of synchronization issues, okay, we have to use couple of things. One is a lock keyword, one is monitor class. So there are two ways, important ways, where you can control or when you can achieve thread synchronization. Okay, so first thing is like, no, I said like, no, there are two ways you can achieve thread synchronization. One is lock. Okay, so whatever the piece of code which is critical for your program, keep that code using the lock keyword. What does it means is, whatever the statements you kept within this open and closing braces, this particular piece can be invoked by only one thread at a time. If three threads trying to access the same piece of code, it won't happen. Whoever is trying to hit this particular piece of code, so they only will be able to execute this particular thread. So remaining two threads, so what happens is, let me so what's going to happen is, I have T1, T2, T3. Okay. So here, when you keep your set of statements, okay, in the lock, right? So these statements are exclusively accessed by only one thread at a time. So it means, so I need to keep this particular piece of code in the lock statement, okay? Because I want this availability of tickets, because this is the one culprit, right? Availability of the tickets is showing 3, right? And 3 different threads are trying to access. So for these 3 different threads, availability tickets contains 3 only, because 3 are trying to do simultaneously same piece of code, right? So when the thread 1 came here, okay, it sees, okay, availability of tickets is 3, so I can book for the thread 1. Okay, and at the same time, thread 2 also invoked, okay, availability tickets is 3, I need only 2, let's book it. And third thread came 3, availability is 3, I need 3, okay, I'm fine, let's book it. So since the same piece of code being executed by the multiple threads at the same time, you get this data synchronization issues. So instead, you say that like, no, at a time only you wanted to access this particular code only by one thread at a time. Either whoever comes first, let that guy, whether T1 or T2, T3, whoever comes first, let that guy execute that piece of code. And if T3 is trying to execute this particular code, right, what happens is this T1, 10, T2 will just simply waits for their turn. So let's say first T3 occupied and they try to execute, and T1, T2 are in a wait mode. Okay, so T3, what happens? They booked 3 tickets, let's say, right? And what happens? Once T3 is gone, then T1 or T2 will come into picture. But now, since T3 already booked 3 tickets, okay, this availability will become only 0. So if it is 0, so T1 cannot book any tickets, T2 cannot book any tickets. Suppose if the locked code being executed by T2, let's say this code, thread 2 is trying to gain the access first. So then what happens? T2 is booked with 2 tickets. I have only 1 ticket left. Okay. Just in case if the next thread is T1, it can book 1 ticket. And the T3 will not say anything. It will simply say no tickets available. Suppose in that case, suppose here also, suppose out of T1, T3, okay, these 2 tickets are gone by T2. Suppose T3 came into picture. Okay, so T3 needs 3 tickets. but I have only one ticket. So it's a no, I cannot book because you need 3. I have only 1. Okay. So let's see, like, how I used lock feature. So if you see here, it's the piece of code is same. Okay, I have invoked 3 threads, thread 1, thread 2, thread 3, and I'm going to invoke or kick off the threads T1, T2, T3. Okay, and just remember, guys, there are couple of things you need to remember. If you wanted to use lock, right? Okay, you have to create one object. Okay, in just a simple object, it doesn't matter. You say like lock object, I'm creating the object. Okay, I'm creating the object of a object class. Just blindly remember that if you want to use the lock feature, you need to have one object. Okay, and you are creating the object, lock object, with the help of master class or parent class or super class, which is object. Okay, so you create a object from the object class and use that class name in the, or use the object name in the lock keyword. Okay, so now you see I did not change anything. The only thing is that first thing is I have created a object for the super class object. Okay, the object name is lock object, and okay, and where whatever the piece I'm going to execute, right, that piece I have kept in the lock. Okay, open braces, closing braces, the same piece of code whatever we have in the previous example. Okay, there is no change here. Let's try to run this. Okay, so T3 first got the chance to use that particular piece of code. So 3 tickets got booked to T3, and since there are no more tickets available, it did not print for other 2 threads. And guys, this results may vary. It all depends upon which thread is going to pick it up first. Okay, now you see thread 1 and thread 2 started first. Thread 1 got one seat. Thread 2 got 2 seats, and obviously there are no more seats. So thread 3 did not book any seats. So it always varies because we don't know which thread is going to execute. Okay, now you see T1 and T2 booked, T3 did not book. So you see the sequence. First T1 came, then T3 came, then T2 came. Okay, it's a guys, it is very, multi-threading is very much important concept. Just stay focused, and if you have any questions, ask me. Okay, so lock is the keyword which we use if you want to keep a particular piece of code that is called critical section. If you want to keep that code to be executed by only one thread at a time. Okay, you just need to create one object for the parent class of object. Okay, and that object name you can keep anything, and you have to use that object name in the lock keyword. Okay, so this is one way of achieving the data synchronization in multi-threading. Okay, so there are 2 locks. One is called exclusive lock, one is called non-exclusive lock. So exclusive lock means only one thread can gain access. So the one which we have discussed in Book My Show, right? That is a classic example for the exclusive lock. Okay, so there are other ways where you can achieve this exclusive lock using monitor class or mutex class, which I'm going to cover, like why monitor class came into picture and why mutex class came into picture. Okay, but there are various ways to achieve the exclusive lock. And suppose non-exclusive lock means, suppose you wanted to execute a piece of code Okay, but instead of one thread, you want to restrict it to 3 threads or 4 threads or 5 threads. Let's say you have 1,000 threads involved in the same piece of code, and you wanted to give only maximum to 4 forks or 5 forks, let's say. Then you use non-exclusive lock. But you see here, the important thing is you are giving the access to the same piece of code by more than one thread at a time. That means you still get the data synchronization issues. That's why it says read-only access. Read-only access. What does it mean is, okay, so okay, you go ahead and give access to more than one thread. That's fine. But ensure that that critical section does not contain any kind of data massaging. Try to keep only a read-only set of code. Don't change the variables value. That way, like you can have more than one thread trying to access the same piece of code, and you will not get any data synchronization issues. So this non-exclusive lock can be achieved using semaphore. Okay. So, just to recap, why do we need multi-threading? Because to achieve the data synchronization. So if you want to use a particular terminology, you can use atomicity. Atomicity. So it means only one thread can access the particular piece of code to prevent the data inconsistency. Okay, atomicity. And okay, so I told that we can achieve data synchronization using lock keyword, and also I said monitor, and also I said mutex. So let's focus on monitor class. Okay, so monitor class, so just see it's a monitor class. In the previously lock, we just used the keyword lock. Okay, but you can achieve the same locking mechanism using monitor class. Okay, so monitor class belongs to system.threading namespace. Okay, and this class is a static class. Okay, since the class itself is a static, okay, and all the methods in that class by default are static methods. So if you want to use the locking mechanism with the help of monitor, since it is a static class, you should not be instantiating the object. You have to use monitor dot, and I said methods also static. So you can say monitor name, monitor is a class name, dot directly access the method name without instantiating the object. Okay. So you see here, this is the static class monitor, and you see all the methods are declared as a static. Okay, monitor and methods. So since it is a static class and static methods, if you want to invoke, you have to say monitor.enter, monitor.exit, monitor.is entered, monitor.pulse, monitor.try enter. Just a class name dot method name. Okay. So if you see if you see entire thing, right? So there are total 6 methods are available. Okay. So first one is enter method. Okay. So enter method means, see in the previous examples, we said lock, right? Same thing. The entry point of the critical section. When you say enter, that means, okay, hey, the next line is my critical section. Let's start the locking. Okay, so it acquires exclusive lock on that particular object. And exit means it's the end of the critical section. Okay, so you no longer required to keep the lock open, or you keep the lock. So when you execute the exit method, the lock will be released from that particular object. Okay, and pulse means, you see, pulse means, see when the current thread, okay, are going to release the lock, let's say, right? If the current thread is going to change its locking behavior, then if you issue a pulse, okay, that means you are sending a message to the other threads which are in the waiting mode. it says, hey, like, I'm almost over. Okay, be ready to access that particular code. Just a signal. Okay, but this cannot be achieved. You have to use one more thing called wait method. Okay, so wait method means, okay, so let's say thread one, entered into the particular piece of code, critical section. Okay, and it requires some kind of other operations to perform. So the thread has a capability to release the lock for some time so that other threads can use of this particular code, okay, for time being. So then in that case, what I can do is, okay, let's say, hey guys, I have 5 more minutes and, I don't want to wait all of you guys to wait. Okay. I have some other things to do. So I will say, wait, I'm going to wait and I'm going to do some other things. So when I say wait, what happens is the lock gets released. Okay. The lock gets released and with the help of pulse, okay, the signal is already went saying that the T1 thread is in wait mode. So other guys can go and grab the critical section. So this two goes by hand in hand. You say wait and pulse. Okay, wait means you're waiting, current thread is being waited, and you are asking the other threads to, try to access the critical section. Okay, and if it is pulse all means, because like you have more than, let's say like in the waiting queue, you have more than one thread. Okay, so pulse all means it will send a message to all the objects or all the threads which are in waiting. Pulse only sends only to the only one class or only one object, but whereas pulse all it sends for all the waiting threads. Okay, and try enter, it is similar to enter. Try enter means, okay, see, when you try to enter or when you try to lock using enter, sometimes that particular piece of code may be already locked by some other thread. We don't know, right? In that case, when you use try enter, you give some time. Hey, I wanted to lock this object, okay, but I can wait for 1 minute or 2 minutes or 10 seconds. Because normally if you try to access enter and if some other thread is already locking the code, it will simply come out of this method. It says like, hey, I'm not able to allocate the lock. Okay, I'm sorry. But in this try enter method, if it is not able to gain the lock on that particular piece of code, it waits for some time, whatever the time you define in that within the method. You can wait for some time before you say like, no, hey, like, no, I'm sorry. Okay. So probably I can explain this after examples. Okay. So let me take you to a couple of examples. Uh, 25. It's 25. Okay. So here, okay, just see here. Okay. I think what I'm trying to do, I'm trying to print. Let me see what I'm trying to print. Okay, I'm trying to print the numbers here. Okay. So let's see thread dot sleep 1 to 5. Okay, if you see here from the main method, I have 3 threads. Okay, thread 1, 2, 3. Okay, and just to differentiate between all 3 threads, I said child thread 1, 2, 3. And for these 3 threads, I am executing the start. I'm just kickstarting the thread with the start method. Okay, so what happens when I declare the thread, I said print numbers is my method. Okay, so print numbers is wait, this is the print numbers method. Okay, so here this is my piece of code. Okay, so now you see here on the at the high level, once the method get executed, I said trying to enter into the critical section. Okay, so here instead of saying log, okay, I said monitor dot enter, monitor class dot method. Okay, and you see I will one variable log print numbers. Okay, log print numbers, just look at the log print numbers. This is again a object. Okay, I said like, you know, whenever you wanted to use the log concept, you have to create one object for the superclass object, right? So same thing I have used here. Whatever the object I have created here, I said monitor dot enter object. This is this object creation is only to, you know, say that like, you know, hey, this particular piece of, okay, this particular piece of thread, a particular piece of code belongs to this particular object. It's because like everything, you know, when we say everything, you know, in C#'s classes, right? That's why they simplified in the using the log concept. Okay, you don't have this kind of methods, but to further simplify, or you know, since C# is all about OOPS concept, so they try to use the class dot method. Okay, so whenever you say, you know, monitor dot enter, it starts the logging. Okay, so if you see here, there are 3 threads. Okay, and 3 threads trying to enter the same piece of code here. Okay, but I have used locking concept. Okay, for this particular piece of code, so basically it prints like, you know, all 3 threads try to print 1 2 3 4 5, right? I value I'm printing 1 2 3 4 5. Okay, so the same 1 2 3 4 5 is being printed by 3 different threads. Okay, and once, you know, it comes to here, right? So this critical section is done. Now I said exit. Exit means the lock gets released actually. Okay, so let's say like, you know, here, so total 3 threads I have, and all I'm doing is printing 1 to 5 using the same thread. Okay, and I have used locking concept using monitor dot enter. Okay, so this is my critical section. Just remember guys, whenever you use monitor dot enter, okay, you have to use this try and finally. It is mandatory. With the lock method, with the lock keyword, you don't need to close the door. In the lock method, lock keyword, you don't need to mention about this try catch finally block. But whereas if you use classes to achieve the locking, you have to use try and finally. So try is the block where you keep your critical code. Finally is like, you know, once you are done with this piece of code, then you come and execute the rest of the stuff here. Okay, let's see. Okay, now let's see here. Okay, so total 3 threads I have created. Okay, and 3 threads, okay, executed the print numbers method, and 3 threads is printing trying to enter into the critical section. Okay, so all 3 threads, thread 0, thread 1, thread 2. Okay, so why thread 0? Because I have using the threads, right? It is a thread of, it's an array of threads, right? So if I use arrays in the threads, normally array starts with 0 index, right? That's why it is thread of 0, 1, 2. Okay, so 3 threads 0, 1, 2. Okay, and try to enter the critical section, trying to enter the critical section. Okay, so total 3 threads trying to come into this particular piece of code, but only one guy got, you know, lock. Which guy? Child 0. Okay, child 0 entered into the critical section. See, child 0 entered into critical section. Then I'm simply printing 0 to 5, 1, 0, 1, 2, 3, 4. Okay, and then child thread 0 exit from the critical section. So I have used this exit and printed. So child 0 is able to gain the access to critical code and he printed whatever is required. Okay, then he just left. Then what happened? We have child 1 and child 2, or thread 1 or thread 2. So now thread 1 again got the chance to access the particular locked code. Okay, and child thread 1 entered, printed 0 to 4, then exited. Okay, then since it is exit, there is no more lock. Again, the second thread came into picture. It got the lock, printed 1 to 4, and then exit. So if you see this particular piece of code, is in a lock, in the locked. That's why you see always these two are going hand in hand. You see thread 0, 0 to 4, thread 1, 0 to 4, thread 2, 0 to 4. Okay. There is. Okay. So this is about using the monitor class. So simple guys, like still you have to use a object. Okay, you have to define one object for the super class. Okay, and instead of trying to say lock, you say monitor dot enter, monitor dot exit. Okay, and then keep everything in the try finally block. Okay, so that's what I'm trying to say here. If you see monitor, right, in the locks concept, you won't need to say anything, just say only lock, that's it. But whereas in the monitor, okay, you will use monitor keyword plus try and finally. So when you use lock concept, okay, internally the system level, it always adds this monitor try and finally block. By implicitly it adds. Whereas with the monitor class, you have to explicitly mention about it, using this monitor or try or finally. It's just that implicit uses versus explicit uses. Okay, so still like since though you are explicitly adding more code for monitor class, still I would say monitor is the best one because monitor has the ability to use different methods. Okay, I explained you around 6 methods, right? Try enter, pulse, wait, pulse all, right? So all those 6 methods you have in the monitor class, but in the lock method and the lock keyword, you don't have this kind of flexibility. You just say only lock, that's it. You cannot say wait, or you cannot say like try enter again. That is not possible. So though monitor is explicitly you need to include more code, but still it has more advantages because it has various number of methods to achieve the required solution for your multi-thread program. Okay, so let me take you one more. Okay, so we have covered enter and exit, right? Now let's try to cover try enter method. Okay, let's try. Okay, so here the same piece of code I am trying to use. Okay, you see here 3 threads. Okay, array of threads 1, 2, 3. Okay, I'm starting the threads in the for loop. Okay, and here the object I'm using for monitor class is lock print numbers. Okay, and here you see instead of enter I should try enter. Okay, and I am mentioning some timeout. Okay, what is the timeout here? 1000 milliseconds. That means 1 second. I'm asking to wait for 1 second. So whoever the thread trying to access the particular piece of code, if they are not able to get the lock on that thread, I'm asking to wait for 1 second. Okay. And I deliberately kept some sleep in between the critical junction. Okay. That way, like, I can show you the difference. Okay. Very simple. 3 threads trying to print 1 to 5. Okay. But I said, use it instead of enter, I use it try enter and kept as 1 second, as a wait time to gain access. So if after 1 second still, if you are not able to get the lock on this particular code, it will simply come out here. Okay, let's see. Okay, so you see here, so total 3 threads 0, 1, 2, okay, entered into critical section. Okay, and out of 3, only one child thread 0 is able to get into the critical section, 0, and printed 0, 1, 2, 3, 4. Okay, then critical thread 1 entered, okay, and you see thread 1 able to print 1, 2, 3, 4, and thread 1 is able to close it. But you look at the thread 3 or thread 2, you see child thread 2 lock was not acquired. So out of 3 threads, only T0 and T1 was able to get the access to the code. Okay, and T3 was not able to access because T2 tried to wait for 1 second, and but still, either it is being used by T0 or T1. Okay, that's why, he said, hey, I'm done. I waited for 1 second to gain access to that particular critical section. I'm not able to do, so I will just simply come out of it. So here what happened for T2, okay, this executed and T2 method waited for 1 second. And since it was not able to get the lock, okay, it came to else spot and simply printed lock was not acquired. It's a time bound. Okay, so this is like, how to use try enter. Okay, and then we have this pulse and wait, right? Right. So let me show you this wait and pulse. Okay. So here I just changed my program little differently. Okay. Here my objective is to print 0 to 20. Okay. So what I'm doing here is I have 2 threads. Okay. To print, T1 is to print even numbers, let's say. T2 is to print odd numbers. Okay. And I want, like, first T1 should execute, then T2 should execute, then T1 should execute, then T2 should execute, like this. That means I wanted to print 0 by T1, odd number by T2, then again T1, even number, then again T2, odd number, like this, up to 20. So basically, I wanted to print the 0 to 20 numbers, but in order to achieve this, I little complicated my logic to say, hey, T1 is responsible to print the even number, T2 is responsible to print the odd numbers. But I want, like, first only it should print only one number, okay, then give the control to odd, then odd should print one number, then give the control back to even. So the control is passed between these 2 threads. Okay, so how do we achieve using wait and pulse, right? Okay, let me show you here. Okay, so here, okay, so I have used 2 methods. One is to print the even numbers, okay, and another one is to print the odd numbers. 2 methods, okay. So if you see here, since it is even numbers, okay. Okay, so let's see here, like, in the try block, try and finally block, okay. I have started my lock using monitor.enter. So lock monitor is the object created using the object class, okay. So I'm using that lock monitor as a object in my monitor class, okay. So here monitor, the lock monitor, and since I wanted to start with even numbers, I said initialization with I equal to 0, less than or equal to number limit. Number limit I have mentioned as 20 here, okay. Number limit is 20, okay. So I equal to 0, less than or equal to 20, I equal to I plus 2, because I wanted to print only even numbers, 0, 2, 4, 6, like that, okay. And I printed the first number here, okay. And now you see the commands I'm executing here. I said pulse, okay. So I'm giving it instruction to the waiting thread, hey, I'm going to release the lock, okay, be ready to gain the lock, okay. So I have issued a pulse, okay. I'm giving a message saying that other thread be ready to catch, because I'm going to release my lock, okay. And you see I said monitor.wait. So wait means my thread is not going to end. It is only for some time. I'm going in a sleep mode, or I'm going to do some other work, okay. So in order to achieve my some other work, I really do not need a lock. So I'm giving the control back to some other threads, so that that thread can access the critical piece using the lock, okay. So you see I issued a pulse followed by wait, okay. And let's see the same for the odd numbers, okay. I just started with I equal to 1, because odd number is starting with 1, but in the even I said I equal to 0, okay. So I equal to 1, okay, up to 20, I plus 2 is by increment, okay. Again I said print odd number, the value, and the same piece, like, I'm let's saying the pulse here, then I'm using wait, okay. So basically, like, I am by issuing this pulse and wait, okay, pulse and wait, okay, I'm taking some breath to take care of my actual work, so that other thread can gain the lock and perform their work, okay. So this is what here, and let's see in the main method what I did is I created two threads, even thread by invoking the even numbers method, for odd thread to invoke odd numbers method, okay. And first I purposefully started my even thread, and I kept sleep here for, like, 100 milliseconds. Then I said start the odd thread. So why, if you see, like, if you see this pattern, after invoking the even thread, I purposefully kept my program on hold for 100 milliseconds. That way, because, like, if I don't keep, when I say your even thread start and odd thread start, there may be a chance that odd thread may gain control and it may print 1. But my purpose is to start with 0. That means I always wanted my even thread to get the lock first. That's why I purposefully kept some wait here. That way even thread can start and at least print the 0 number to start with. Okay. So then I said, like, I'm just joining these two methods, right? Why to join? Because if you want your main thread to be waiting for the completion of child threads, you have to use join, right? And let's see here. So it's simply printed 1 to 20. And since I have used join, my main method is waiting for the completion of child threads. Okay, so using wait and pulse, I'm printing one number and issuing pulse and wait. So odd number thread can gain control, and odd number printed value 1, Then again, we went to pulse and wait mode. So the control went to lock or even method, and even thread printed number 2. Again, I have issued pulse and wait. So the lock released from method from thread 2 or even thread, and the lock went to the odd. Okay, so beautifully, like, it's a simple logic, but I just to explain that, we have used this. So print one number, okay, and issue pulse and wait. That means first even, then odd. Okay, pulse and wait. So first odd even threads kick-started, printed value 0. Then I have issued pulse and wait. That means this thread is temporarily on hold and lock got released. So the lock acquired by the odd thread, and odd thread printed one number. Then I said, like, issued pulse and wait. So odd number released the lock, and it which is being caught by even number again, and even number printed one more number, and it went to pulse and wait. So since the lock released from even, the odd gained the control that particular code and printed one number. So it's like repeating, like, one number print from the even thread, one number printing from the odd thread. Clear, guys? Pulse and wait. Okay. And okay, so I think pretty much I covered all the critical or important methods in the monitor class. Okay, so now let's see the, I just try to put it in the pictorial way, okay, how this monitor class works. Okay, so now right, monitor.enter is the method, okay, to start your threads. Okay, and if you issue monitor.enter for more than one thread, okay, all will be in the ready queue, but only one thread will gain access, okay, and they will get the lock, and that thread will use or execute the critical piece of code. And once the critical piece of code is done, then we issue monitor.exit to release the lock. That way, whoever the threads which are in the waiting queue, okay, they can, okay, gain the control or gain the lock on that particular piece of code. So monitor.enter, monitor.exit, okay, and pulse and wait, right? This is how it works. Okay, so now okay, so here I will try to explain, like, now we have lock monitor, right? And we have mutex class. Okay, so if you see so far, whatever the threads we are creating, they are getting created by our application program itself. Okay, within our program, we are creating the threads, okay, and we are allowing only one thread to gain access to the particular piece of code. Okay, but let's say, like, in C#, .NET is a big framework. There are lot many third-party libraries, lot many DLLs available. Okay, and suppose if the threads are being coming from beyond your program or above your program, okay, the thread is coming from the outside, not inside the program, from outside. Okay, so that means external threads are coming. If external threads are coming, and if you want to implement the locking mechanism for external threads, you have to use mutex class. Okay, so lock and monitor is only specific to your program or your class. Okay, but if the threads are coming from outside of your program, then you have to use mutex. Okay, you see, lock and monitor only internal threads, and only one thread can get into the critical piece of code. But in the mutex, you have external threads trying to gain access to the particular code, and only one thread can access. You have to use mutex. Okay. Let me show you how mutex works. Not execute. Okay, let me show you how this mutex demo, right? Okay, let's see. Let me put some comments here. Okay, see here. Let me build this program. Need this logic. Okay, just simple, a simple print statement. Application is running. That's it. I'm not doing anything else here. Okay. So it is a mutex class demo, right? I'm trying to open the executable file, mutex class demo, in bin folder in debug method. Okay, you see this mutex class demo. Okay, I'm trying to run this program. Okay, I have one application is running. Okay, one more I entered. Okay, let's see here. I have 3 different threads, right? See, application is running. So 3 different threads are being executed without any issues, right? See, I'm invoking, outside, from outside, I'm invoking this file, this program. So I have the ability to execute more than one thread without any issues here. But suppose you want to limit this, you can use mutex class. So we can use this one only. Let me close this. We will use the same program only. I will uncomment some piece of code. Here, now I will try to do the same thing using mutex class. Okay, I will explain later, but I will first show you the how it works. Okay, I try to use the mutex class. Okay, I saved and save as is coming when I try to save. Okay, that's fine. So I just did a build already. Okay, build succeeded. Okay, now see, I'm trying to execute now here. Okay, so it says application is running. I'm trying to invoke one more. Okay, let's see what's happening. See, an instance of application is already running. Since we have another thread already running, okay, it did not allow. It accepted only one thread. That means, see, just see that, I am trying to access from the outside, right? Outside, I open this. Okay, so since I have used mutex class concept, I was able to restrict the access by only one thread. Okay, so let's see how I should this. I have used a mutex class. Okay, so using is the keyword you have to say mutex and say new mutex. Okay, so using the mutex class. So whenever you use mutex, only one thread will run. Okay, and if there is no other threads running, it will print the application is running. If any other thread is running, it will throw this error. Otherwise, it will simply, you see here, like if this is false, if already someone else, this is important. Wait one. Wait one means it will see if anybody else is already using the lock, or if someone else is already executing that piece of code. It will say that it is already being used. If it is nobody is using that particular thread, it will execute this particular piece of code. So two things. One is I'm introducing mutex keyword here, mutex keyword. Second thing is wait one. It will see if any other thread is running. If it is running, it will say that, hey, someone else is using this particular piece of code. You are not allowed to use it. If not, it will say it will simply go ahead and execute your piece of code. So mutex is, remember, mutex is basically to gain access to only one thread, which is coming from outsider, not from the within the program. It is coming from the outside of your program. So I just, showed one more thing here. I have 5 threads. And I said thread dot start. And the method name is mutex demo. So it comes to mutex demo here. So total 5 threads, right? So I'm printing here wants to enter critical section of program. And if you see here, I'm using try and finally block here. And you see, first thing is I am waiting. I'm seeing if anyone else is accessing this particular piece of code or not. If no one is accessing, it will print the message and sleeps for 2 seconds. Then say, the task is completed. So for mutex, you have to remember 2 critical important methods. One is wait one. Wait one is basically, to wait for the current thread to release the lock. If someone else is releasing the lock, you can go ahead and grab it and start using or start executing your piece of code. So wait is to wait to get the signal from other threads, and release is to release the lock from the current thread. So 2 methods, wait one and release mutex. Let's see. Let it complete. So your particular piece of code here, right? Total 5 threads, right? And this is common for every thread, but only this particular success and exit. This is only at a time only one thread should access success and exit in combination, right? You see here, say success and exit. You see thread 3 only started success and exit, right? Then thread 1 success and exit. Thread 2 success and exit. Thread 5 success and exit, and thread 4. So this is how you can use the mutex class to implement synchronization. So there are, guys, there are a lot many methods you have in Mutex. Okay, I just only introduced a couple of methods. So it is your responsibility to go back and check or explore further about these concepts. Okay, so there are a lot many methods available in the Mutex. Okay, because I just wanted to, because if I'm going to cover all the methods, it will take a lot many classes. Okay, so that's not I wanted to do here. I'm just covering that. I'm just kickstarting the important stuff so that you can, read other material and gain more knowledge. Okay, so fair enough. We have log, we have monitor, we have mutex. Okay, what else we have? Okay, let's see. Okay, so we have semaphore. Okay. So if you remember, when I explained at the beginning of this class, I mentioned that, we have two kind of logs, exclusive and non-exclusive. Using non-exclusive, you have the ability to gain the access to the particular piece of code or critical section by more than one thread. Okay, so that's what I tried to put here. Using semaphore, okay, you can gain access from external threads, and you have the ability to access more than one thread also. Using Mutex, you can only access one thread at a time. But semaphore, it allows you to access more than one thread can access the critical section of the code. Okay. And okay, so I'm skipping the program here. I will share the programs here because we are just running short of time. It's already 7:10 for me. Okay. So I will provide this examples, okay, after this class. Okay, and this is the one I wanted to cover today. Deadlock. Okay, so most of you heard of this deadlock, How many of you are familiar with this deadlock? I think this comes in database also. During your academics, do you know, what is this deadlock? Okay. Okay. So here, deadlock means, okay, it's like, threads are in a hung stage. They are not able to move forward. Couple of threads, they simply hung. Why? Because one thread is waiting for the other thread to release the lock, and same way another thread is waiting for the other thread to release the lock. So if you see here, I have two threads and two different resources. Okay, and I want lock on these two resources so that I can achieve my task. So what happened? Thread 1 locked resource 1, okay, and it is trying to lock the resource 2, but it is not able to lock because thread 2 already locked resource 2. Okay, so that means each thread locked one resource and they want another resource to be available for them to complete their work. So thread 1 is waiting for resource 2, which is being already locked by thread 2. And thread 2 is waiting for the resource 1, which is already being locked by thread 1. Okay, so basically, it's a deadlock. I cannot move forward. Both of the threads cannot move forward. Okay, so this is the deadly combination, so this makes our programs very inefficient. So we have to handle very cleverly, to avoid this kind of deadlock situations. Okay, so how do you do? Okay, how do you do that? How do you achieve this, to prevent these deadlocks? Okay, so I have already told about this monitor.tryEnter, where you have the ability to wait for certain amount of time. Okay, and within the certain amount of time, if you are able to gain the access, you go and execute your piece of code. Okay, suppose in the here, okay, so thread 1, I was able to get the lock. Okay, thread 1 is trying to gain access to resource 2, right? Here you can say, hey, I am trying to access resource 2. I can wait only up to 5 seconds. If I'm not able to get the lock on resource 2, I will simply release my locks on the resource 1 and I will just free up. I'm not going to, continuously invent time. I'm going to not wait for resource 2. I will wait for 5 seconds, 10 seconds, or 1 minute. Then if I'm not able to get the lock, I will simply release it. That means, so each thread can wait for a specific amount of time. And if they're not able to gain control within a specific amount of time, they will be releasing the particular lock on the other resource. Okay, so in this case, suppose T1 locked resource 1 and it was not able to gain lock on the resource 2. It waits for 5 seconds and it releases resource 1. What happens then? Thread 2 will simply come and grab the resource 1 and execute their steps. Okay, so it's using monitor dot try enter. Okay, now let me Saroswati.
Hello.
Yeah. Okay, let's see here. Okay, so this is the, I'm just trying to show like how this deadlock can occur. I'm just giving you one. So guys, you're okay to wait for another 10 minutes, right? Or, if you want, I can take a break and I will explain this tomorrow.
No, we can take this tomorrow. There's no one in the call.
Oh, okay. Oh, really?
Yeah,
Okay then. Okay, so this last concept we'll cover tomorrow.
sure enough.
Okay. Yeah.
Yep.
Thank you so much. And both the Vamshis. So is it you only joined? It's a
Thank you.
okay. Yeah. Thanks, Vamshi. Two Vamshis.
Yeah,
Okay.
everyone went for a party.
Oh,
There's
really?
no one in the call.
Oh, guys.
Yeah.
Okay. Okay, that's fine. Okay, so we'll catch up with the remaining stuff tomorrow. Okay.
Yep, sure
Yeah.
enough. Yep,
So, guys,
thanks for the class, man.
Yeah, thanks and enjoy your party. Bye.
Yeah.